Hi everyone, this is Dr. Vijay from EC Department, SNS College of Technology. Here we are going to see the topic Dynamic CMOS Logic from the subject VLSI design. So in this video we are going to see the difference between the static and dynamic CMOS logic, and then general structure of dynamic circuit logic, recharge and evaluate modes, and then advantages and disadvantages of the dynamic CMOS logic. So in this slide we are seeing the static CMOS structure in which the inputs are given commonly to the pull-up and pull-down network. So we will be having 2n transistors in this circuit. N represents the number of inputs. So meanwhile in dynamic logic circuit the structure is little bit different from static logic. So this is the example structure for the static CMOS logic, equal number of transistors in the pull-up and pull-down network. So here is a comparison between the dynamic and static CMOS logic. So in the figure A we are seeing the static CMOS logic in which we will be having 2 into n transistors. But in the dynamic logic, if we are seeing right hand side diagram, we will be having only in the pull down network n number of transistors are there, and in the remaining transistors are utilized for clock signal, connecting the clock signal. So this is the structure of dynamic CMOS logic. So here the clock signals are given when equal to 0, it is considered as precharge mode. When the clock signals are given equal to 1, it is considered as evaluate mode. So in the evaluate mode, the output is pulled to low value compulsorily. We are seeing what if pull down network is on during precharge. So during precharge mode, if pull down network is on, then all the transistors will be switched on, means then the output path will be discharged and everything will be grounded, every signal will be grounded. That is why we are connecting NMOS transistor additionally with the clock signal in the foot path. So this is the general structure of dynamic CMOS logic, where we are having PMOS transistor and NMOS transistor connected with the clock signal, and in between we will be having the pull down network. So on the output path we are having the capacitor which makes the charging when the signal through the output path is there, and discharging when the pull down network is on. So here representing the precharge and evaluate mode. If clock equal to 0, that is called as a precharge mode. Then the PMOS transistor connected with the clock signal will becomes on, and NMOS transistor will become off. So likewise, when the clock signal is in evaluate mode, that is clock signal equal to 1, the PMOS transistor will become off and the NMOS transistor will become on. So here is the comparison of the different logics like static CMOS logic, pseudo NMOS logic, and dynamic CMOS logic. So here the circuits are connected based on the different logic structures. So the general advantage of dynamic logic. So it will be used for high speed cascade circuits, and it will be used for the less number of transistors is the main advantage here. Only n plus 2 transistors needed, whereas in static CMOS logic it is 2n transistors are needed. Comparably it is using very less logic, and no static power dissipation is the another main advantage. Then coming to the limitations, we are having monotonicity, charge leakage, charge sharing, capacitive coupling, clock feed through. So the rising time and fall time of the output varies based on the change, that is delayed based on the changes in the clock signal from precharge to evaluate mode. So that is called as a monotonicity, so which may leads to the wrong output. So that is the main drawback of this dynamic logic. And here is the example waveforms. And then charge leakage. So even though we are using the capacitors for charging and discharging in the output path, so there will be micro level of charges that they will be discharging from the capacitor when the circuit is in working or ideal. So because of that, the output signal will be degraded. So that is called as charge leakage. Similarly, we are having clock feed through, capacitive coupling, etc. So coming to the end of this video, so we have seen about the static logic structure and dynamic logic structure, and what are the advantages and how the structure is functioning and limitations, and we came to the assessment. So in the assessment, we are seeing the difference or comparison between the static and dynamic logic. So here based on the different features like basic principle, transistor count and application, the static logic always connected to VDD or ground. Output is always connected to the VDD or ground. But in dynamic logic, output is stored through a capacitor using precharge and evaluate mode. So it is better. Dynamic logic is better. So and then transistor count, so more PMOS is needed when compared to the dynamic logic. So here also dynamic logic is better, and in applications, general CMOS logic circuits we will be using static logic, but in high speed logic we will be using the dynamic CMOS logic. So that is the right answer. So list out the dynamic logic problems: monotonicity, charge leakage, charge sharing, capacitive coupling, clock feed through are the different limitations of the dynamic CMOS logic. So and how monotonicity problem will be solved. So because of the delay in the output, we will be, that is because based on the rising time and falling time delay, so there will be false output in the circuit, which can be overcome with the help of the domino logic. So that is the end of this video. So we can join in the next video. Thank you all.